give you uh, the overview of what you should have done for these few weeks. As you know, your test 2 has covered chapter 3 and chapter 4, estimation and hypothesis testing. And then you look into chapter 5. Okay, you learn chapter 5 on goodness of it test, independence test, and homogeneity test. Okay, and you notice this chapter is not yet tested, but it is part of your assignment. It is part of your assignment. So look at assignment question later, where you can apply this skill from chapter 5. And then chapter 6, analysis of variance, a very important chapter. In final exam, usually you have two versions of this chapter. One is manual calculation, another one is based on Excel output. Okay? You are not asked to carry out the Excel analysis, the analysis using Excel, but you need uh, to test your skill on how to interpret Excel output. So this is part of the final exam that has been practiced for quite many semesters. Okay, so um, so by that okay performance by that experience from the last semesters, it is not impossible to have this at least one question based on Excel output. So you need to know how to interpret the Excel output. And not only in final exam, also in your assignment, you have to use analysis of variance to solve one of the questions. One of the questions in your assignment. For simple linear regression and correlation, also like in ANOVA, you have two options. You have two approaches that you have to master. That is to analyze the simple linear regression, okay, using Excel, as well as correlation. How you get correlation from Excel, and also from manual calculation. Okay, from manual calculation, i.e., you can use your calculator to get some of the estimates of the regression model and the correlation coefficient from your calculator directly, and then how you interpret those values. Okay, so in assignment also you do have the this chapter 7 on simple regression and correlation that you should apply and use to answer one of the questions in assignment. Okay, so before we go into assignment, let's just go through again, but this time on chapter 6, analysis of variance, and also simple regression and correlation. I just want to summarize the detail. Okay, all the details are in the videos. Okay, I don't intend to give you another lecture because the video is already complete. Okay, so you need to go to the video to get the details. What I want to do now is to summarize. Okay, to summarize. What is the difference between one way ANOVA and chapter 4, test of hypothesis? Okay, uh, where is the connection between chapter 4 and chapter 6? There is a connection. Okay, when you talk about testing a difference between only two means, okay, only two averages or population average, only two, and that is in chapter 4. Okay, we talk about testing mu1 against mu2 when the sample sizes are small and the population variances are unknown, and you assume the population variances are equal. In other words, you have case 3a. You have case 3a. That is in chapter 4. But if you extend, instead of testing a difference between two means, now you test a difference between more than two means. You have mu1, mu2, mu3, and so on until mu k, for example, where every sample you have small sample sizes. Okay, so you have small sample sizes. N1 is small, N2 is small, and so on. So in that case, you cannot use chapter 4. Okay, you cannot use chapter 4. Last time we had an example where a student, when we asked about testing mu1, is it equal to mu2, is it equal to mu3, what he did was, he tested pair by pair. So he tested mu1 against mu2, mu1 against mu3, mu2 against mu3. So he tested 3, okay, 3 statements. So in that case, of course the answer is out. Okay, so it's not acceptable. We are not targeting that kind of answer. Okay, when you test mu1 equal to mu2 equal to mu3 or not, then it has to be under chapter 6, analysis of variance. Okay, so although the name is analysis of variance, where in fact you test between different means, but what you actually do is looking at the variations. Okay, variations. If there are different, then of course the variation will be different. Okay, but if the variations, okay, between groups and within groups, okay, if the ratio of the variances are equal, and equal to 1, i.e. the variations are the same, then in that case you say on average they are the same. Okay, so that's why the name is analysis of variance. Okay, analysis of variance. You test a difference between the averages by looking at the variation, by testing the variation. Okay, between groups variation and within group variation. So so that's why you have this one way ANOVA approach. Okay, so any questions so far, guys, on one way ANOVA? Hopefully, you all have watched the video and can get the idea. Is there any question that you want to post regarding chapter 6, guys? No question so far. Hopefully, no question so far means you understand the chapter, yeah? You can do the chapter. Yes, very good. And then you do have equal sample size and unequal sample size case. Okay, there shouldn't be any problem with these cases. Equal or unequal, if you follow the procedure, okay, the procedure is actually very straightforward and actually the same. Just that for equal sample size, when you have n1 equals to n2 equals to n3 and so on until nk, then the capital N is just the sum of all n's. So you can just take k times n, something like that. But I don't want you to confuse. You just sum all the n's. Either it is equal or unequal. So basically the capital N is n1 plus n2 plus n3 and so on until nk. No matter whether ni's are the same or ni's are different for different j. Okay, nij. So you have the same equation for different cases, equal or unequal. Okay, and even the other equations is SST, total sum of squares, or SSTRT, the treatment sum of squares. the formula are all the same. Okay, you just apply the same concept. Doesn't matter whether you have equal or unequal sample sizes. Okay, the worry is that this is the worry. The worry. Most of the time, you do have the data arranged column by column, meaning the first class, the first group is listed in the first column, the second group in the second column, the third group in the third column, and so on. And this is exactly the pattern and the approach that the default approach used in Excel. You have the groups arranged in columns, but at times you can have the data arranged in rows. You can have the first group in the first row, the second group, the second level in the second row, and the third group or the third level in the third row, and so on. So you need the ability to identify which is the target the target group. Is it by column? Is it by rows? Okay, you need to be very careful because if you got this wrong, everything will be wrong. Okay, for example, you have 5 rows. Each row give you um, each level. Okay, and supposedly you have the same, especially for the same or equal sample size case. Normally, students will be confused when it comes to equal sample size. For example, you have 5 rows. Okay, 5 rows, and then 10 columns. For example, 10 columns. Okay, of values, observations. So if you are not very careful, then you tend to say the 10 the 10 columns will be the K or the 10 groups, whereas the data are arranged in rows. In rows. Maybe you have like 4 rows, for example. Row 1 is level 1, row 2 is level 2, row 3 is level 3, and row 4 is level 4, where each level contains 10 observations, for example. So some students tend to say the K is 10 or 11, for example. Okay, and then each of the 10 levels have four observations. So in that case, you need to be very careful. Yeah, we do have this kind of question in the past, and yes, we do have students who did wrongly on this analysis of variance when we arrange the data in different order. Okay, in different order. So please, you can have the data ordered by columns or by rows. Usually in Excel, we use by column, but you can also have by rows, but you have to to state clearly, the data are arranged by rows. Okay, by default, Excel understand the column level, not the rows level. But if you want to use the row, that's fine. But you have to tick by row in the Excel environment. But in final exam also, you can have data arranged in rows or in columns. Okay, so just be careful on that note. Other things I believe very clear, very clear. You need to know the sum of squares, the total sum of squares, how to calculate the treatment sum of squares, and then how to get the SSE, and then put everything in the one-way ANOVA. This is very crucial. One-way ANOVA table, you have to know in and out about the ANOVA table. What should be in the first column of the table, what is the second column, what is the degrees of freedom, how you get the mean square, due to treatment, mean square due to error, and finally, what is the test statistic in the ANOVA table, the F test. This is the one that you should calculate. That's why you have the ANOVA table, because you want to get the F test. And please follow the standard calculation, the standard way of developing the ANOVA table. Okay. Well, some students are very smart. Okay, they can see things through. So I don't have any problem with that, students. Okay, you want to arrange as you like, but at the end of the day, you get the correct F-test value. That's fine. But for some students, they don't know what they are doing. They just follow. This is a problem. So F-test is the ratio of mean square due to treatment to MSE, and the ratio between MSTRT and MSE. So MSE has to be the denominator for F-test or calculated F value in the ANOVA table. Okay, so to get the MSTRT, you have to have the SSTRT over the K minus 1. Okay, the degrees of freedom due to treatment. So you need to trace back the ANOVA table. MSE is the mean square error divided by the degrees of freedom due to error. So you have to trace back the ANOVA table. That's why ANOVA table is actually a summary of this one-way ANOVA method to get the F-test value, the calculated F value. So if you put in different arrangement there, then you will have a problem. Okay, you will get wrong F value. Okay, so just be careful. The first row, of course, you have all the titles. Okay, the source of variation, the sum of squares, degrees of freedom, the mean square, and then the F test. The second row of the ANOVA table has to be what the treatment. Okay, the treatment, the factor. So you have as the next, you have the sum of squares due to treatment, you have the degrees of freedom and so on. So you follow through the table. The third row is the SSE, the error, and the error for the error. And the last one is the total. Okay, so make sure you have the correct arrangement for the one-way ANOVA table and fill in the values correctly in the correct cells so that you get the F-test value correctly. Okay, that's basically on the one-way ANOVA. And the way you write down the hypothesis statement has to be correct. Yeah, you notice even in test 2, some students are so lazy to write down H0, H1. You know H0, H1 give you a mark, at least 1 mark. Okay, so please write down H0, H1. So you have to write down the H0, H1 correctly for one-way ANOVA. And you can see you have 2 options. If your question is asking about whether there is any difference in the means, then of course H0 involve the mean. So you have mu1 equal to mu2 equal to mu3 and so on until mu k. Whereas under H1 you have mu I not equal to mu j for at least one ij. Okay. However, if the question is asking you whether there is any effect, then you have H0. Under H0 you have alpha 1 equal to alpha 2 equal to alpha 3 and so on equal to alpha k equal to 0, i.e. no effect. No effect. Whereas if you have any effects, then alpha I has to be not equal to 0 for at least one I. So when you say no effect, means the means will not be different. Okay, when any treatment or factor has no effect on the observations, then you expect the mean for every group will not change. Okay, or they will be the same, and on average they will be the same. But when there is an effect, okay, for example, if the temperature give some effect to the observations, then by group they will be different, and the mean will be different. That is the relationship between the effect and the difference in means. So look at the question. Sometimes students don't care whether the question is asking about effect or difference in means. They put the same statement. At some stage, we don't mind. Okay, we don't mind. the next steps of the testing will be exactly the same. Okay, the same. You are still using F-test, and then you are still compare the F-test with the critical value, which is only one side on the right. Okay, this is one-way ANOVA. Although you have um, mu1, mu I not equal to mu j, not equal to under H1, but in terms of the um, rejection criterion, the decision rule, you still say reject H naught if F test or calculated F is greater than F alpha. Okay, one-sided on the right. You don't have two-sided F test in ANOVA. ANOVA. Okay, so please look through the videos step by step. Clearly get the idea. Only one-sided test for one-way ANOVA. Although you have H1, mu I against mu j. Mu I not equal to mu j for any ij. Okay, for any pair of the data. Okay, so that's the things about one-way ANOVA lah. Again, I ask you any questions so far, guys? So, doktor, kalau data tu, if the data in rows, kena kira K dekat dari first row, kan? Okay. So, let's say if I can share with you an example, okay? Let me... Okay, let me share with you an example to get things clearer. Okay, I share with you Excel environment. Okay, usually you have like this. Okay, supposedly 1, 2, 3, 4. Okay, 4. And then you have values. Okay, so whatever lah value that you have. Usually it happens when the confusing statement will be on equal sample size. This is just an example. Okay. So if I say you have 4 level, I don't say 4 levels, but I say okay, the observations according to different types of products, for example, different types of product. I don't say how many types, which observations, but you know, some of these values must be observations, right? Okay. So the types of product. Okay, the types of product. Maybe in the question, it mentions something. The types of product. 4 types of product, for example. 4 types of product. So, for example, if I put like this, if I just change this, delete. So, 4 types of product. 4 types of product. So, could be like, if you notice like this, okay, the data is arranged like this. Okay, 4 types of product. If you read very carefully, if you say types of product, it can have you should have like type 1, 2, 3, 4, isn't it? Type 1, 2, 3, and 4. So if I put like this, everyone I think everyone would understand your level will be, your data will be like in rows, in columns like this. Okay, in column like this. So very clear. Oh, I should put like another 4 types. Okay. Maybe I should put another one. Uh, Here, I remove this one. Okay. If I remove this, so I say 4 types of product. Okay. So by uh, if I put like this, most of you would say, okay, you have type 1, type 2, type 3, and type 4. That's fine. Okay. What if I put like like this? Okay. I remove this one. The same question. 4 types of product. 4 types of product. What would you say? Okay. So here, some of you could think that you still have rows like this. So you tend to get, okay, data analysis. Where's my data analysis here? Data analysis. So what you do, you will use single ANOVA, where your input range will be this one. Okay, and you don't even put okay, here labels in the first row. This is when you have okay, when you have the usual one, you have label in the first row. But since we don't have label, okay, so if you put labels in the first row, what happened? Okay, so your group is actually group 1, 12, 13, and 17, and that is not supposed to be. Okay, not supposed to be. This is the usual practice. Okay, you put the label in the first row, whereas in this case, the label should be in the first column. Okay, the groups are group 1, 2, 3, and 4, and the observations are this one. Okay, so you can see the difference, the different output. Okay, so if you don't put this, meaning by right, the first column is the hold on, sorry. So what happened if you put this instead? So if you put single factor without this, without the label, okay, what happened? Okay, so in Excel, you need to be careful when you do the Excel analysis. But in final, I'm talking about in final, when you have this kind of data, 1, 2, 3, 4 should be the group. Okay, 1, 2, 3, 4 should be the group, and the data should be from here. Okay, the data should be from here. So group 1 will have data observation. You can see the observation should be around the same values. It's not like starting from 12 and jumping out here and there with different numbers. And usually observations will be appearing in random. Okay, you don't have like your observation to be like in ordered values like this 1, 2, 3, 4. So then your row 1 should be this. Your group 1 should have these observations 12, 13, 17. Okay, not this one 2, 3, 4. And then second group will have this. So this is wrong. Okay, this is wrong. So you need to be very careful whether your data are arranged in columns or in rows. Okay, so just be careful with that, because if you get things wrong in the early stage, everything will be wrong. Okay, will be wrong. So be careful. And if you use your Excel, make sure to state whether you have the rows. You have the rows to be labeled or not. Okay, because if not, this is what happened. See, it counts all the values. Okay, all the values as observations, including 1, 2, 3, 4. Okay, where your count data, your observations should be only 3 here for every group. So for every group, it should be 3, but the groups has to be correct lah. So to play safe, you put the values in columns so that you can click label in the first row, and then the rest will be observations. Then will be correct. So in this case, is also wrong, because if you put label but the label is not in the first row, okay, it is in the first column. So you transpose first. If you have in rows, then you transpose first into columns so that you can get the first row to be the label, and then things will be correct. So be careful with your data. Okay. So that's basically on one-way ANOVA. Afiq Najmi, do you have any problem with that? Are you clear?
No, doctor. Very clear, very clear.
Very clear. Okay.
So doctor, if we don't want make it row, can we make it into the column? Can?
For your assignment, yes.
Yeah.
And I expect that to happen because if you look at my videos, okay, the videos are showing you how to use Excel by using the column. The column. The column will be your groups. The groups are arranged in column by column, so that the first row will be the label. And then the observations will be in the other rows. So the groups are arranged in column. Okay, so that you can run the hypothesis, run the analysis in Excel correctly. Okay. But in final, you don't have to transpose it. You can just straight away get the first row to be the first group. And then you just calculate the total, the level total, and what is important in the formula, you have to have the level total. When you want to find the SSTRT, isn't it? So the level total, so you total up the first row values, the second row will be the second row total, the third row will be the third row total. Okay. So that will be the correct way lah. You don't have to rewrite the values and so on. You just need to find the row total. Okay. If the data are arranged in column, then you get the column total. For the total, for the group total, isn't it? The yi dot. And the yi dot, y1 dot, y2 dot, y3 dot, and so on. Okay. It's just a matter of whether it is in column or it is in rows. But if you have to like rewrite the values, it takes you so much time, isn't it? So what you have to do is just to get your calculator, get the row total or column total, depending on how your data are arranged. Okay. So that's basically on chapter 6. Okay, what about chapter 7? Okay, chapter 7. Hold on a second. What's chapter 7? Let me share again. Okay, the summary for chapter 7, you have two parts, simple linear regression and correlation. But simple linear regression is actually, I would say, the most, I could say around 7 out of 8 portion of this chapter 7 is on simple linear regression. So what you aim for is to get a model, okay, a regression model, the simplest one, which is the simple linear regression model, to relate one dependent variable to another independent variable, predictor variable. So you have dependent variable, response variable, the y, okay, the y variable. So y is dependent variable or response variable, whereas another variable is x, which is the independent or predictor variable. Okay, predictor variable. So you want to see whether y has any relationship with x or not. Okay, so you model y as a function of x. Y depends on x. Simple linear regression of y on x. So you have to be very clear which one is dependent, which one is independent, which one is response, which one is um, predictor variable. Okay, so we use y as the response variable and x as the predictor variable. So y is a function of x. If there is any relationship, okay, there is a relationship, then you can expect y is a function of x. Okay, so if you have like, so later on you will get a fitted linear regression equation. Okay, a fitted linear regression equation. So you can expect to have y equals to, or y cap equals to a plus bx. Okay, that is a linear function. Okay, just assume that you have y cap here. Okay, so I put y cap. There's no equation on cap here. So you have a fitted y equals to the alpha cap or a plus beta cap, which is b times x, where a and b here are the coefficients of regression equation, and the regression coefficient, the estimate, a is the estimate of how to say, the estimate of intercept, and b is the estimate of slope. Okay, so you have a linear function here. So you need to be careful what is your y, what is your x, because if you got this wrong, these two variables wrong, okay, then you will get wrong equation, because regression equation is one-way function, one-way function. Okay, when you talk about y on x, it will be y as a function of x. Okay, in reverse, if you have x on y, then you have x as a function of y. They are not the same. Okay, what happened? This is what I want to say. What happened? Sometimes in a question, you can be given the values of x first, followed by the values of y. Okay, so in your calculator, you press the value of x first, followed by y. So you have to insert the values pair by pair, right? So you have x1, comma, y1, and then insert the data in your calculator and plus, for example. Okay, and then you follow by the second pair, x2, comma, y2, and plus, and so on. So I'm talking about model 570 MS. But for ES, you can do the same thing. You put x values first, followed by y values, and you do that for all pairs. That's fine. Okay, for this data, that commonly given as x first, followed by y first, then okay. But sometimes you're given the y values first, followed by x values. Okay, so this is the thing that in the past students failed to do correctly. Okay, because they enjoy this chapter very much, they like this chapter very much. So whenever they got the data, they just plug in the data without taking into account which one is actually your dependent variable, which one is your independent variable. So please pay attention to the data, which one is your y, which one is your x. Okay, usually you look at the prediction. What do you want to predict? Of course, you want to predict the dependent variable. You want to predict the response variable y. Okay, So in that case, y, the response variable, the one that you want to predict is y. Okay. Usually the x value, the independent variable value is known, and you can control the x values. For example, you want to predict y value for a certain x value. So from there you know which one is x, which one is y. Okay. So before you insert your data, before you use your calculator, make sure you identify the data correctly. No matter how your data are given, whether it is x first followed by y second, or you can be given a table of y values first followed by x values. Okay, so that's what I want to highlight. So once you get the uh, fitted line, okay, the fitted equation, then you can do prediction for a given x value. What is y? And that is the target. That is the aim for getting this or to estimate this simple linear regression equation. Okay, and I want you to bear in mind that just recall from what you did in chapter 5. Chapter 5, when you did independence test, here you also have an analysis on a relationship. Simple linear regression is an analysis on relationship. So what's the difference between independence test in chapter 5 and simple linear regression in chapter 7? They both can be used to analyze relationship. Okay. So again, be very clear. Okay, I already told you last time. Relationship that you learn, the analysis on relationship analysis on relationship using independence test. That is the analysis on the relationship between two two um, categorical variables. X and Y are categorical. Okay, categorical. Qualitative. Okay, qualitative variables. Whereas in simple linear regression, the scope for your course here, simple linear regression, Y and X are quantitative, numerical values. For example, the weight. Y is the weight. X is the height. So both are quantitative. Whereas from the chapter 5, independence test, when you learn about whether the faculties are independent or not with uh, the activeness, whether students being active in co-curriculum or not. Okay, so you identify whether students who are active, okay, doesn't depend on whichever faculty they come from. So the faculty, so you have the faculty of science, the faculty of engineering. So those are categorical variables. And then being active or not, you classify the students into being active or not. Again, categorical. So you don't have numerical variables in independence test, whereas in simple linear regression, you learn about relationship between two quantitative random variables. So that's the difference. And for simple linear regression, you don't need the contingency table. Whereas for independence test, yes, you need to summarize your data into contingency table. Okay, the cross validation table. Okay, so hopefully you get clear idea. And of course, we have to assume that the data are normal, and then you can do the testing. The test is only on beta, not on alpha. You don't test on alpha, you only test on beta. And the way you test beta, you can have two-sided test, or one-sided on the right or one-sided on the left. If you focus on testing whether there is any relationship, so you have two-sided test. If you focus on testing whether there is any positive relationship, then you have right-sided test where beta is greater than 0 under H1. When you test about a negative relationship, then you have under H1 beta is less than 0. So you need to be careful with the statement of the question, okay? Are you testing two-sided? Are you testing right-sided? Or are you testing left-sided alternative hypothesis, okay, for simple linear regression? Okay, that is the testing. And for testing any relationship, okay, any relationship, two-sided test, you have two options, either to use t-test and to use f-test. And this is what happened. You have to use this approach for your assignment. Okay, where you can do Excel only focus on two-sided test, whether there is linearity. Meaning you have, it could be positive, it could be negative, so you take two-sided test, okay, for testing linearity on the regression so that you can use t-test or f-test. Okay, Excel give you both. Okay, the f-test and the t-test for two-sided alternative hypothesis under simple linear regression. What about adequacy of regression model? How do you know that your simple linear regression model is adequate to explain the relationship between y and x? Okay, so you look at the R square value. Okay, R square value. For simple linear regression, of course, it is safe to use R square. Although if you look at the literature, the use of R square to be have to be done with care. You need to be very careful when you use R square to identify whether your model is adequate or not, especially when your regression model is not simple linear regression. Okay, you could have multiple linear regression. So in that case, of course, every time you have more random variables, then your R square will increase. So we don't have to worry about the multiple linear regression. It's not in your scope. Okay, you only focus on simple linear regression, so that's fine to use R square to check the adequacy of your regression model. So R square value is the coefficient of determinant. Okay, so you can use that. Usually, if R square is above 67% or 70%, that should be okay. Okay, and usually the higher the R square value, okay, it implies that your correlation coefficient is high as well, because R square is just R square, the correlation coefficient square. Okay, whether a correlation coefficient is negative or positive, so you have, when you take that squared, so you have R square value, and that R square value is in your Excel. You can get that in Excel. This is very important in your assignment. Okay, um, but sometimes in the past we do have a question based on Excel output where the R square value is given. So the question can ask you whether the simple linear regression model is adequate to explain the relationship between y and x. Okay. Transformation, we don't really look into transformation actually. Sometimes when you have a linear regression model, it is not really linear. Okay, so to make it linear, you transform. Instead of talking about x alone, maybe you can make use of exponential of x, but we don't really look into that now. So you don't have to worry about transformation. You can suggest when your R square is low, you can suggest that further analysis should be done, and one way is to look at the transformation for the random variable, could be exponential of x or log of x and so on. Okay, but you don't have to run through the procedure further. Enough for you to just make suggestion. Pearson product moment correlation coefficient, or simply sample correlation coefficient, which is R. So you need to know R. Usually in exam, we just ask what is R, what is your comment on R, this kind of thing. Okay, and even you can get the R value from your calculator directly. And as I mentioned in the video, two things that you have to mention what are the direction Is it positive? Is it negative? And the strength. Is it very strong? Is it moderately strong? Is it weak correlation coefficient? Okay. Is it very weak? So you know, any R value going or move towards zero, that shows a weaker. The strength is getting weaker between Y and X. Okay. But if it moves towards one or negative one, you can see a very the relationship is getting stronger. Okay, either in negative direction or in positive direction. And you can also see from the scatter plot, if the scatter, okay, are very small. Okay, the scatter not widely scattered. Okay, the scatter is small. Okay, around very close to each other around a line. Then you can say the relationship is strong. Okay, in that case. But if the scatter is wide, okay, the scatter is wide, then the correlation is weak. Okay, so that's basically from the scatter plot you can have a feel whether the relationship is strong or not. But to measure the strength, then you need the correlation coefficient or the sample correlation coefficient R, so that you can give your idea, give your suggestion on what kind of strength that you have and between Y and X. Is it very strong? Is it moderately strong or very weak and so on? Okay, right. Any questions so far, guys, on simple linear regression and correlation? No. Okay. So if you don't have that question, that's fine. For your assignment, oh dear, for your assignment, let me just give you a very brief explanation. So let me stop this video. Okay. Hopefully we have still time. Okay, 3 minutes. Let me see, where is it? Okay, here I do have assignment brief. Okay. Can you see my assignment brief here? Okay. So assignment brief. Well, if you look at your e-learning, you have the groups. The groups are already divided. So I should put. Hold on. Did you see the groups in the e-learning? Okay, let me see whether I get the groups. If you can spend a little bit time, I will explain this. Let me see whether I have another one. This one. Hold on, Okay, this one. let me, which one do you see? Okay, I close this one. So you should have, this one. Can you see with the groupings?
Yes, better.
Yes, okay, good. Let me record, okay. Okay, Bismillahirrahmanirrahim. Hopefully you can spend a little bit more time, say 10 minutes with me on this assignment. Okay, I need to brief you on the assignment. Okay, I've already shared with you the groups. Hopefully you do use the correct data for your group, for your own group. For example, data pil lajak kuruh tablet A, yeah, that should be for group 1 and so on until group 15, and then group 16 use F and group 17 use I. Okay, so here you will use the data, and what happened, you have this lajak laku manufacturer which produces the tablet called lajak kuruh. Lajak kuruh ni orang Perlis ke. Okay, and then so you do have this, and what do you need to do? So you do have a problem here. Okay, the manufacturing operations common problems accounted include fluctuations and so on. Okay, it is important to ensure tablets uniformity at every batch produced, so that further corrective measures can be taken at the shop floor. So this is about the data. So every group, every tablet, you have these observations 200. Okay, 200. And then in that 200 you do have data observations from morning, evening, and night shift. Okay. So what do you have to do? Of course, submission will be on the 31st January 2021. So it's about less than 2 weeks from today. Okay. And what you have to do? Describe and summarize the sample data. Okay. So I expect you have like numerical summary and also graphical summary. Okay. So the numerical summary you can find using Excel. If you look at that Excel output, look at Excel data analysis, you do have the summary, how to get the descriptive statistic. Okay, descriptive statistic. So if you have data analysis, okay, data, and then put data analysis, you do have descriptive statistics. Okay, so if you click descriptive statistics and then select your data, so it will give you summary statistics with confidence level and so on. Okay, so you can try to do that, and then of course once you have the summary statistic, you need to summarize in words, in wordings, what happened to your data. Is there any difference from the eye view between the means, for example, and so on. Then I also expect you to share the graphical summary. Maybe you can plot box plot or histogram or whatever based on your data, and see whether there is any difference between the shifts and so on. Okay. Where is it just now? Here. All right. So that is the descriptive summary. Okay. Either numerical, graphical, or tabular. Okay, tabular form. So you need to be creative to answer this part. Part B. This is where you need to use your chapter 5, goodness of fit test, where on the H0 you have whether the weight, and the weight, here the weight, here the weight, your variable is normally distributed or not. Okay, on the H0, the weight X is normal with mean 350 and variance 14 squared. Okay, so what you have to do, since your data are in observations, raw observations, then you have to reconstruct. Okay, the table. Maybe you can use different worksheet. Put in, you classify the data into different intervals, and then you identify the frequency, how many observations are within certain intervals, okay? And then you run the goodness of fit test, okay? Using the chi-square test and so on. So this is part B. So I'm giving you the hint here, okay? For part C, this is where you need to use chapter 6, isn't it? You want to comment whether there is any significant difference between the tablet weights. mu1 against mu2 against mu3, where 1, 2, 3 are the shift. Morning shift, afternoon shift, and night shift. So you have a comparison between 3 and significant. This is significant, yeah? With T here. Significant difference. Is there any significant difference between mu morning, mu afternoon, and mu night shift? Okay, so testing a difference between more than 2 means, that requires chapter 6. And then the part D, here you want to see, you want to study the relationship between relative density and tensile strength. So which one is your Y, which one is your X? So you look at what you want to predict. Yeah, predict. So here, what are these? Okay, you have the relative density and tensile strength. Okay, and then recently a batch was found to produce classes of tablets that show low relative density values of this. Okay, and then the question is, what is the prediction of tensile strength for such tablets? So here you can have an idea. Which one is your Y? You want to predict tensile strength. So tensile strength has to be Y, because this is what you want to predict. So of course the other variable, which is relative density, will be your X, your predictor variable. So you predict tensile strength at these values. 68%, 74.3%, and 80.1%. So 3 predictions, and then comment on the validity. So how do you comment on the validity? So you can only say that the model is valid. Your simple linear regression equation is valid only if the values you use to predict, which is the values of X, where X is the relative density, okay? If the values are within the given range. So you need to look at your raw data, whether this value 68% and so on are within the range given in your data. So you look at the minimum relative density, maximum relative density, and see whether these values are within that interval, okay, between minimum and maximum. If they are out of the range, then you can question the validity. So you can say that the model is not valid to predict the tensile strength. Why? Because the values used to predict is out of the given range. Okay. Otherwise, if they are all in, okay, if any of this, okay, or is in the range, that's fine. The prediction is valid for that particular value. Okay. So look at your data and comment on that. Okay. So submission, you have to submit one PDF file. So this is the written report and one YouTube link. For your group, maximum is 15 minutes. Other groups, they might use 10 minutes, but I give you more time so that you are relaxed when you present. But it's okay if you want to submit 10 minutes or 12 minutes, that's fine, as long as not beyond 15. If you give more than 15 minutes, I will not watch, and penalty for the video. Okay, maximum 15 minutes only. So I will share with you the submission link. Okay, and please, hopefully you can okay, cooperate between yourself. If you do have problems with your team members, I have to remind you that if I get any complaint from any of the members, your mark will be jeopardized. Okay, you could be penalized unless you give me evidence that your friends' complaint are baseless. Okay, so if I do get any complaint from any members that you don't cooperate, you don't do your part, and so on, you could be penalized. And especially for YouTube link, for YouTube video, okay, if I don't see your face in the video, of course half of the mark is gone for you alone. Okay, for you alone who don't participate in the video. Okay, so this is like um I want everyone to participate. I want everyone to cooperate. Okay, so you learn, okay, by doing this, not only the content, the technical skills that you can obtain, but for your future lifelong learning, you learn how to cooperate between yourself. Okay, because later on you have when you work, these are the skills that the industries look for. Okay, the cooperation. Okay, how willing you are to complete a particular task. Okay, guys. So I guess that's it for today, and I believe the data are very straightforward. You do have the data in Excel, and in the Excel you do have different worksheets for different group. Okay, so you look for your own group worksheet. Okay, from where you get your data. Only focus on your data. Don't look at other data. Okay, you can copy paste, but don't alter any observation, because I will mark your assignment based on my result. So your result and my result has to coincide, has to be the same. Only that I want to see how critical, how innovative, how creative you are to present your result. Okay, so that is the aim lah. Instead of course, you need to know the content, the technical skills that you must obtain from the group task. But I want to see how you summarize that and present that to the top management here. Okay, so hopefully you can do the assignment within the time frame, and I will share with you the link for submission next week, inshallah. Okay, guys, if you don't have any question, I think that's it for today.
Right, Doctor. Okay.
Okay, thank you very much. So
Thank you,
I
Madam.
see you again on Monday, inshallah. Okay,
Yes, Doctor.
Assalamualaikum warahmatullahi